Our goal for today is to be able to find the surface area and volume of a sphere. The volume of a sphere has a formula of 4 pi r squared. Now, surface area or lateral area, all of those pertain to spheres because they simply have one surface. And so it doesn't matter what it's called. It can be called the area of a sphere, the surface area, or the lateral area. It's 4 pi r squared. Volume is 4/3 pi r cubed. The pi r cubed, that's the hardest part. That's the part that people forget, is that cube right there, because they're so used to pi r squared. So what this looks like in a problem, it'll say the radius of a sphere is 12, so we know that r is equal to 12. Find the area and find the volume. Here's a good example. It just said area. The area of a sphere, so you want to pay attention to that. Always write your formulas first. Area is 4 pi r squared. We're looking for area, so area is equal to 4 times pi times r squared. You can just type that in on your calculator. 4 pi and then times r squared. And you get 1,809.6. Sometimes you might see it where it looks like this. This is called exact, 576 pi, and this is called approximate because I had to decide that the rest of those decimals were not important. So this is exact form. Volume is 4/3 pi r cubed. Again, watch, make sure you get that right. So 4/3 pi r cubed. So to the power of 3, there's several ways that you can do this. So 4/3, that's 4/3, and then times pi times r cubed. So you use this little caret key, okay, to the power of 3. 738.2. Now, you can also do 4 times pi times r cubed, and then divide by 3 at the end. You can also do your fraction 4/3, and then pi, and then r cubed. And then also, if you go to math, and you go down to number 3, there's a cube symbol too. So you can also do that. You can do 4/3 pi and then r cubed and go that way too. So whatever way sticks with you and helps you to remember which way you need to do it. So that is all things spheres. Let's look at some problems. What if it's a hemisphere? Okay, so this is a hemisphere. It is half a sphere. Now, what if it's just a bowl, like an empty bowl with no top? So that would be, you would want your area with no circle on top. It's just like a cantaloupe or an open bowl, right? So then that would be 4 pi r squared, and it would be half of that. So you can deal with this however you want. You can take half of 4 and just do 2 pi r squared, or you can find 4 pi r squared and then divide by 2 at the end. Just don't forget to divide by 2. That is 100.5. Or a hemisphere is the same as 2 pi r squared. If the whole sphere is 4 pi r squared, then a hemisphere would be 2 pi r squared. Now that's if I don't want to include a top. But what if I have a lid? What if I put a lid on top and this is actually a solid piece? Then you would take that 100.53, you would take that number right there, and you would add the circle on top, pi r squared. So we would take that original number that we just found, the bowl, which is the outside of the bowl, right? And then add pi r squared. You get 150. So it all just depends on whether it is a hollow bowl or whether it has a lid on it, or if it's a solid, like you took a foam ball and cut it in half and it has a solid surface. Okay, the volume is 4/3 pi r cubed, and it's half of that. I recommend, because of all the fractions, that you do the 4/3 pi r cubed. And then you take that number and divide it by 2. Just don't forget to divide by 2 at the end. So I recommend that you handle it like that, because then it makes sure that you don't make any mistakes. Now, it's 4/6 or 2/3. 4/3, half of 4/3 is 2/3. But I recommend that you just find the whole thing and then divide it in half. A couple of word problems that go like this. The diameter of a standard basketball is 9.5 inches. That's the diameter. Okay, diameter equals 9.5 inches. If the basketballs are covered in rubber to the nearest tenth of an inch, what is the minimum amount of rubber needed to manufacture a set of 4 basketballs? Okay, so first you have to decide, is this a volume question or is it an area question? It is an area question because we're covering something. Remember that volume is filling it up and surface area is covering it. So we definitely want to cover it. So if we find the area of 1, so 4 pi r squared, so it would be 9.5 over 2 squared. Now, this 4 is not because there are 4 basketballs. This 4 is because the formula for the surface area of a sphere is 4 pi r squared. So we're going to take this right here. Now, you can do this in pieces, right? 9.5 divided by 2. That is 4.75. So that is actually my radius. Okay, so if you want to do in order, then 4 pi and then r squared, 4.75 squared. That is the area of 1 basketball, right? 283.53 is 1 basketball. Okay, that is for 1 basketball. I want to know what it is for 4. So you would multiply that by 4. Take that number, don't round it until the very end. Multiply it by 4, you get 1134.1. So you get 1134.1 inches squared of rubber to cover the ball. Okay, so make sure that you don't mistake the 4 in the example or in the equation for the 4 that's in the problem. Typically, you can rent a standard 242 cubic foot, so that's a volume measurement, helium tank from a local gas supplier. You can go over to Party City and get a helium tank to fill up balloons at your house. If you assume your balloons are spherical and are 1 foot in diameter, how many balloons can you fill with 1 tank of helium? All right, so we have a balloon. We're going to have to make an assumption that our balloons are 1 foot in diameter. Okay, so 1 foot in diameter means that they have a radius of half a foot. So we want to know how many balloons can we fill up if we have a volume of 242 cubic feet in a helium tank. So find the volume. So one way you can do this is find the volume of 1 balloon. The volume of 1 balloon is 4/3 pi r cubed. Okay, it said cubic feet. That's how I know. And it's air. We're filling it with gas. And we're filling it up. That's how I know it's volume. 4/3 pi r cubed. So that is the volume of 1 balloon. Okay, that's the volume for 1 balloon. So I want to know how many of those I can get into 242 cubic, out of a 242 cubic foot helium tank. If we take that 242 cubic tank, right, 242 cubic feet, and each balloon takes 5,236, and then some cubic feet of air, then I can take 242 and divide it into this many segments. So I'm going to take 242 and divide it by the amount of volume that I need for each balloon. And I can do 462 balloons. Not 462.2 balloons, because you can't round and you can't do 0.2 of a balloon. If it had been 462.5 balloons, you can't round up to 463. In real world, sometimes the rounding rules don't always apply. So we can do full 462 balloons if they have a radius of half a foot. Okay, so surface area or area of a sphere is 4 pi r squared. That is covering the surface of it. Volume is 4/3 pi r cubed. Be really careful with that. That's volume. That's filling it up with air or whatever it is. It's how much space it takes, all completely solid. Okay. So be sure that you're careful with those formulas and watch out for that r squared and that r cubed.